Hello everyone, this is Andre.
Hey everyone, Ariel here.
I hope you're all doing okay in quarantine. I know it's been a really long time since our last lesson, but we're really excited to get back to doing science with you. So if you remember all the way back to last lesson, we talked about processes that shape the Earth's landscape, and we talked about weathering and erosion. Today we're going to continue talking about processes that shape the Earth, starting with the structure of the Earth. Now the Earth itself is a big ball, like that. And inside the ball, there are a bunch of layers.
What we have here is a diagram of the inside of the Earth. It's as if the Earth was cut in half and pulled apart. What we see are the inner core, the outer core, the mantle, this yellow layer, and the crust, this green layer. The inner core and the outer core are made up of metal, iron, and nickel. The inner core is solid and the outer core is liquid. A lot of heat is trapped in the inner core and the outer core. That heat helps heat up the mantle. This will be important in a few minutes. The mantle is kind of like the consistency of peanut butter, where it's kind of like a solid and kind of like a liquid. The lithosphere, or the crust, is a solid, hard to move and very brittle.
Let's review this by drawing a diagram in our notebooks. We'll start with the inner core and the outer core. Together, these hold a lot of heat. They get really hot, over 8,000 degrees Fahrenheit. That's as hot as the surface of the sun. Next we have the mantle, which is that peanut butter-like substance. Don't eat it though. And finally the crust, where we all live. This contains the oceans and mountains and rivers and everything we know.
Remember when I said the inner core and the outer core get a lot of heat to the mantle? This is important because then the mantle heats up and it goes through a process we call convection. Convection happens when you boil a pot of water. Heat at the bottom of the pot causes water to rise, move around, and sink back down after it's cooled once it's risen to the top. If you follow my arrow, it kind of does this motion where it rises, moves, and falls. We see these arrows here that show the movement of the convection. Here we have mantle rising, moving to the sides, and falling. This is causing the movement of the crust. The crust is moving on what we call plates. The crust is made up of these plates that create new land in volcanoes. It also creates new land at the middle of what we call a mid-ocean ridge. And it also destroys old crust when it sinks underneath these volcanoes. So what we have going on here is a lot of plate tectonics.
The crust of the Earth is made up of a bunch of tectonic plates. Now these plates are really big and move really slowly, under 1 inch per year. That's far too slow for us to notice that they're moving when we're living here, but over long periods of time, they move quite considerably. In fact, if you got a time machine and went back 100 million years, back to when the dinosaurs were around, you would see that the map of the world would look very different. The plates float atop the mantle much like boats on the water. As the mantle does convection, it carries the plates across the surface of the Earth as shown. As the plates move, they can grind against each other, moving apart or towards each other, and this can completely change the landscape at their borders, which are also called fault lines.
Plate tectonics has 3 main types of interactions. Well, we have our divergent plates, where crust moves apart from each other. We also have convergent plates, where crust moves toward each other. What's not pictured here is something called a transform plate boundary, which we will get to later.
Now that we all know a little bit about plate tectonics, let's do an experiment. Click here to see the experiment and follow along at home.